continue from there. If last week was an introduction to networking, where we talked about the core services required for connecting different resources in AWS together, establishing a base network, then we could think about the stuff we learned this week as being more advanced networking. We saw last week that with a VPC, subnets, a router, and an internet gateway, we could host an application on an EC2 and have it accessible to the public. And we could assign a domain name using Route 53. So all of those things that we learned last week allows us to deploy an app and have it be connected to the general public. So what we cover this week is going to be more use case specific resources. And let's start with, and today we're starting with, like you mentioned, network access control lists, virtual private networks, and direct connect. So if I share my screen, I may have mentioned this last week, but I'll repeat it again. Because if I did mention it, it would have been very, very brief. We did cover security groups quite a few times, and we talked about security groups as being a layer of security, right? Now, it's not the only layer of security because we have network access control lists as well. And before we go any further, let me just see if I'm missing anything. Right. So this week, we are going to continue learning about VPCs and VPC security through things like VPNs and Direct Connect and NACLs. And we are also going to cover scalable messaging services like Simple Notification Service, Simple Queue Service, which I know a few of you, like Paige, already have experience with. And we'll end the week talking about load balancing and auto scaling. And you can think about all three of these, I guess, groups of topics as being advanced networking, right? They they aren't crucial to the most basic foundational structure of like a network, right? Because we saw last week we were able to do that without this extra security, without these messaging services, without any kind of scaling. But these are still important resources because they, well, no one's going to argue the importance of security, right? And we can't really neglect the value of things like auto scaling because when you get that application out in the real world, it's going to have to be able to handle increasing loads of traffic. That should at least be the end goal when you have an application and your goal is to get users, right? So we can think of these topics as supporting networking or being more advanced networking resources. And then next week, we will just talk about some final core services that are going to be covered in the first two tiers of AWS certification, and then we'll kick off our assessment. So that's the big picture look at AWS, the AWS module in a nutshell.
How does the assessment timeline look?
You will release it on Saturday,
Hmm.
and you will have a week to work on it.
Okay, so Saturday is Saturday, essentially.
Mhm.
Okay, cool. Thank you.
Is this the 14th or the 21st?
This next Saturday, so the 21st. And the way that grading works is you will meet with the instructor of that day and basically talk through your assessments one-on-one in one of the breakout rooms. And you will be given the rubric, so you'll know what objectives to hit for the assessment, and then you'll just follow that along together with the instructor. And once you're finished, then you could go ahead and destroy all of your resources. All right. So going back to today, we are talking about network access control lists. And like I had already mentioned, you could think of this as being an additional layer of security. Let's look at this image to kind of give us a better picture of what that really looks like. So here we have everything within a VPC. What should be familiar to you already is these inner sections here where we have our instance within a configured subnet with a security group, and it's connecting to a route table. But what you might notice now is in between the route table and the security group is a network ACL. So why have multiple layers of security? Well, it's more secure for one, and they can they can defend against different types of attacks, for example. They can catch security at, let's say, well, this graph doesn't really demonstrate. I was hoping for an example where we have one ACL connecting to two different subnets because we can't do that. So you'd have separate security groups within each subnet, but then a broader layer, the ACL, for the different subnets to connect to. And so that's an example of one possibility of how you could use these two different layers, right? But if we were to use an analogy and think about, I don't know, all of these resources as being like a community, right? So this is maybe the VPC is like a small town, and each subnet is its own little neighborhood within that town. So within the neighborhood, you have instances, which would be like houses, and each house has their own security, like a lock on their front door, maybe a security system. So that would be your security group. And then maybe this neighborhood is one of those fancy gated neighborhoods, and that would be your ACL. So multiple levels of security, again, it's good practice. Is it absolutely necessary? As we saw last week, no. We were able to set up our resources without using an NACL. We'll see that they are configured a little differently. And let's see, what's this example scenario here? Consider a scenario where a developer accidentally misconfigures a security group, which allows SSH access from any IP, for example. The NACLs then serve as that additional layer of security, right? It can still prevent potential attacks despite the exposure at the security group level. So again, multiple layers of security means more security. Now, this management is also centralized because they operate at a subnet level. They're useful for providing broad sets of rules that make sense to apply to a range of instances within the subnet. And this can also give the benefit of standardization, having a uniform application of rules across the subnet. And then there is a default deny rule where by default it's going to deny all traffic that's not explicitly allowed. So this is another way NACLs can help prevent misconfiguration and security vulnerabilities as a result of that. So let's look at some use cases and maybe a few more differences, I guess. So NACLs are stateless, whereas security groups are stateful. And I think I'm not remembering exactly why that matters. So NACLs are stateless. That means they do not keep track of the traffic flow the way that security groups do, which are stateful. And as such, security groups automatically allow return traffic. Right. So with NACLs, there's an added layer of configuration, which again makes for more security. In a way, you could think of NACLs as being more particular about how you configure them, whereas sub security groups are a little more forgiving. We'll see inside of the UI. Actually, let's look at it right now. We'll see here, for example, that we have, just like within a security group, different tabs for inbound and outbound rules. And we have that default rule that we were talking about, right? So both have this explicit deny rule for all destinations, for all sources. Now that might look strange at first, right? Because how does that work? How do we have a rule that explicitly denies alongside a rule that explicitly allows? Don't those two things conflict? They do. But one difference between NACLs and security groups are rule numbers. So when it comes to a security group, let's security groups, and we look at one of these rules, we don't see that, right? We don't see the number here. When you have a group of rules, maybe a better example from something that actually has rules. When you have a group of rules, all of these rules are going to be met simultaneously. Like there's going to be checks for all of them, right? They coexist very peacefully. Whereas within an NACL, rules are a little more, I don't know if linear is the right word, but there is a flow to how these rules are applied, right? And it's incremental. If the conditions are met for any rule, that's where the logic stops. Like that um, that connection will be denied if it hits that rule. Otherwise, it's going to try to go through and look for the first rule where, like, let's say the port range matches, the source matches. It needs to fall within a range, right? The IP needs to fall within a range specified inside of the source. Otherwise, that rule's just not going to apply to it. And then if there are no rules that are created that apply to it, it's just going to hit that final rule, the explicit deny, and it will be denied entry. So basically, it needs to be allowed by all of the rules that are specified. And that's just different from a security group. If a security group doesn't have any rules at all that pertain to the connection that's that's being requested, that connection is going to be allowed. Where by default with an NACL, it's going to be rejected. And now outbound traffic, when you have your internal services trying to communicate externally, there's also that same complexity. There has to be specific rules set to allow for that outbound action. Otherwise, it's going to be denied. Let's look at adding a few more rules. And I think if we look at today's, well, no, let's go back to that. Let's go back to adding rules a little later on, and let's see if we could run through anything else here. So each NACL rule is evaluated independently and in an ascending order, just like we discussed. Like security groups, rules can be used to allow or deny traffic, but again, the difference is these rules are evaluated in an ascending order. Inbound rules are evaluated first, and then outbound rules are evaluated. And again, they are evaluated in order of their role numbers. So once a match is found between a rule and the traffic, the rule is applied, and then the following rules don't need to apply. The connection is either allowed or denied. And if, right, again, it just follows that linear flow. Okay. Going back to, yeah, flow.
I just had a quick question. Would we ever have a case where we have an inbound rule set up, but we don't have its corresponding outbound rule? Because I noticed the verbiage in here, it says inbound rule share evaluated first, and if the traffic is allowed, outbound rules are evaluated. So obviously you need inbound rules in order to have the outbound rules.
Yeah. Now, let me think. With API requests, you typically always get a response after you make a request, right? Because the response is going to let you know if the request was successful or not. So is there a case? Well, yeah, I think there are cases that you can connect without necessarily requiring SFTP, for example, right? You can connect to an external server via SFTP, and there's not necessarily any outbound traffic, just the inbound. Yeah, I think that's that would count. Okay. Yeah, Julio.
Just to make sure, I see right there stateless and stateful.
Mhm.
Stateless is when you have to allow it both ways. So you have to allow uh, inbound and outbound. Is that correct? Or is that stateful?
It's stateless, but let's see. What's a good way of explaining this? Yeah, when it says that NACLs do not keep track of the traffic flow the way that security groups do, which are stateful, that's the reason why you have to specify both the inbound and outbound is the NACL has no way of um, remembering that the traffic coming in through that inbound connection is an entity and so associated with the outbound request. Whereas a security group will do that by default. It will, by being stateful, be able to keep track of the traffic going in and out of it.
Gotcha. Okay.
Okay. So NACLs are applied to all instances within a subnet, and security groups are applied to individual instances. Yeah, I guess this image represents that. I think I don't know if it can be a little more clear, but yes, we have multiple instances within this one subnet. They each Oh, here. Yeah, we should be looking at this side. Each instance is looking at a different security group, right? But they're also going to the same ACL. And if we go back to our, right. So I think in the first example I mentioned that the image doesn't show that it could cover multiple subnets, but it can. So an ACL can be associated with multiple subnets. Okay. So it can be used to allow or deny traffic based on IP address, port, and protocol. That's the NACL. And the security group is the same, but I think there's the addition of denying traffic by exception. I'm not really sure what that is referring to. Well, we've covered the core differences between these two. We know that they are security existing at a different level. They are configured a little differently, with ACLs being a little more particular about how you configure them. ACLs, and part of being particular is ACLs being stateless, which requires you to then specify rules for both the inbound and outbound traffic, because by default, the catch-all rule at the end will deny service or a connection. And that's not the case with security groups. With security groups, they're stateful, so any traffic trying to make a connection within the security group will not require the additional setup of the outbound rule, the implicit setup of that. And let's see what else. Yeah, those are the core things that differentiate the two of these. And in our challenge today, we're going to set up an ACL with multiple rules, and we'll go over that in a second. Before we do, let's just run through VPNs and Direct Connect. So we could go through the challenge in one go. So the VPN is a service that establishes secure cross-premise connections between your on-premise data. Who here has connected to a VPN before? Okay. So you've already got some familiarity with that. And usually when you connect to a VPN, that will allow you access into something within that network. So for example, like let's say you're trying to access some kind of a resource, a work resource, maybe something like a database wherever you work, or even like a front-end application. And all of this is gated to only be accessible to anyone that's been authenticated. And one way to do that is through VPN. You have to be signed onto the VPN with the proper credentials in order to access any of this network's resources. This is a very small image, so let's see if we can zoom in on that. So one common use case, right? Like if we have both on-prem and cloud services, a VPN connection can be the pipeline between that customer gateway and the network behind the virtual private gateway. These are additional resources that will be setting up a virtual private gateway, which basically acts as the door into this private network, and the customer gateway, which is a representation of the entry point for this kind of network. And we've talked about the internet gateway last week as being an entry point. So if we think about that internet gateway as being a front door, it's open to the public. Anyone can access it if they have the URL. We could think of the customer gateway as being a backdoor. You can only access it if you are able to sign into this VPN connection. Okay, so there are two types of VPN connections. We have the AWS site-to-site VPN, which is, I think, all we use in today's challenge. This is what requires both the customer gateway and the virtual private gateway. The customer gateway again represents like an on-prem router. It could also be used just as a cloud resource. And then you have your virtual private gateway, which is what it attaches to your VPC within AWS. And the client VPN is another connection option that consists of an endpoint and software to connect to that endpoint. So you might go to like a portal, right? A URL on a web page somewhere that has login input. You put in your username, you put in your password, and then this browser sends a request to this VPN endpoint. And then you get a response which either denies you or allows you. And you utilize some kind of VPN software to do all of this. So we're not going to be setting all of that up. I think it's a bit much for now. So we're only going to be focusing on a site-to-site VPN today. And for the sake of your assessments, that's all you're going to need to use as well. As you're reading through these resources and studying for certifications, just remember that there are more than one type of VPN. Okay. And then there's Direct Connect, which is a separate service entirely that allows you to establish a dedicated network connection between your on-prem data center and AWS. I don't know if today's challenge goes through this. I think we're really just including it as a topic. Yeah. Yeah, we don't really use this either because we don't really have we don't have an on-prem data center. It'd be nice if we did. We've tossed around the idea of having some kind of a server at the actual physical office that students could use as a playground, but that has yet to be a thing. So, well, we could just really talk about this briefly. This direct connection, you configure it just like you would expect with a port, circuit, a virtual interface, and that's what then connects to the virtual private gateway. And if we want to look at what that looks like through an architecture diagram, here we have our cloud resources, the VPC on the right, and in the middle, this direct connect system. Our on-prem server will connect to one of these. Well, it will first connect to this router, this partner router, and then it hits an AWS Direct Connect endpoint. And from there, it authenticates to either allow you or reject you from hitting whatever resource you're trying to hit within the VPC. Yeah. Again, it's here.
Doesn't Direct Connect, just quick question, doesn't Direct Connect actually require like someone coming out, like physically working to get that connection directly through AWS because your resources, like it's like a private connection between you and AWS, like your resource in AWS, and it never really hits the internet or anything like that. Like it's a actual direct connection to AWS if it's available in your location.
Right.
I
Yeah.
might be thinking of okay.
Yeah. And we don't, yeah, like I said, we have no way of,
Yeah, we can really do it.
yeah, so it's kind of really just included here as an honorable mention because the topic theme is again like some advanced networking configurations, and you might have to deal with this wherever you land. So it's included for now, but yeah, again, it's not really going to be covered in any of the assessments. And I think there might be a few more things that are kind of like that. This week in particular, we don't cover CloudFront. We mention it, but it's not really going to be used in any of the assessments or anything either. We're primarily going to use API gateways. So I don't know. You give us feedback if it's helpful or not helpful to have all of this additional data that doesn't get tested in the assessments, and we could adjust from there. But that is essentially NACLs and VPNs. And today's challenge will have us utilizing our VPC to set up an NACL and VPN. This first part's just to verify existing resources, and that's really just running through the AWS console and refamiliarizing yourself with where everything is, right? We're going to want you to then run through that process again and actually, let me close some of these tabs because I have way too many tabs, and actually create um, another VPC. So, right, once you're done reviewing the settings above, recreate them with your own resources. So, what was I trying to? Oh, right, just one of these. From there, we will create a dummy gateway to represent a customer gateway, and we will then create a virtual private gateway. We connect it with a VPN connection, and we will update the route table for the private subnet. It looks like there's a lot of steps, but they're like quick steps. I think this is where we do try to be more granular with where the resources are within the UI. So you should be able to follow this without getting lost. And because we don't really have a lab today and really just have the challenge, I'm not going to demo all of that. I'm going to let you do it on your own. And all I really want to be able to show you is setting up these additional rules. So let's look at that. We want some additional rules. And right now we have these default rules, one with the explicit allow and one with the explicit deny. So let's try adding a new rule. We're going to edit well, let's go back. I want to edit our inbound rules first. We're going to edit our inbound rules. And if we want to set these specific rules, it is done so like this. You add a new rule, you add a rule number, and remember the rule number is really what determines where in the waterfall of rule checking this rule gets checked, because these rules get run in a linear fashion in ascending order based on the rule number. So if we were to set this rule, if we wanted this second rule, this new one, um, where we allow SSHing from an IP, if we want that to happen before we allow for HTTP access, then we want to set a lower rule number. If we want it to happen after, then we set a higher rule number. For now, it looks like this is so, oh, I see. If we make this rule 130, or I guess to follow this example, specifically rule 129, this is where we can set the rule for HTTP, or no, sorry, this one's for SSH. And we want in allow. We'll then add a new rule, rule 130, and this one's going to be for HTTP.
Is there a reason why the rule numbering is 3 digits?
I don't know. I mean, maybe it's just to give you the right amount of flexibility in creating a system of rules, right? Because maybe having like 1,000 rules is a little excessive, but only having access to 10 is not enough. Yeah, that's yeah, I think that's just specific to how these were designed in AWS. So here we are setting a rule for port 80. We'll set another rule for HTTPS connections, which uses port 443. And then finally, we set one last rule, again for SSHing, but this time we set this to be an explicit deny. And I think what happens in the challenge is you are supposed to create an EC2 in one of these instances, and then you will try to confirm these rules are working by trying to connect to the EC2. And then you could try reordering these rule numbers and seeing how that changes your ability to connect or not connect. Okay. And that's about it. Everything else you should be able to do because you've done it before. And we'll have somebody demo their run through of this tonight when we reconvene before destroying your resources. Sound good?
Sounds good.
I will open up breakout rooms, go ahead and take a break, and I'll see you all back here at 9.
Julius, I have night shift work this week. I'm starting at 9,
Okay.
so I can still I can still be in the meeting. I just won't be able to talk because I'll be in another meeting from 9 to 10. That's
Okay. Cool. Yeah, that works. Thanks for the heads up.
all right. Thanks.
All right.